So, okay, so we are talking about this. So I said you about lambdas, and yes. So I was talking about function recursion, right? So function recursion required three statements. One is called initialization statement, and second one is condition, and third one is update statements. Okay. Function recursion required three statements: initialization statement. So there is a condition, and so there is one more statement which is called as update statement. So we are trying to do with the three statements here. So I said, what is a recursion is? Okay, recursion is like repeating or calling the function itself. If you're calling the function itself is called as a function recursion. It is just like a looping statements. For example, repeating the same function number of times. Okay. Repeating same function number of times is called a function recursion, right? Repeating the same thing number of times. So what is the meaning of this is, for example, there's a function 1. So function 1 is having argument, and I'm trying to say print. So print hello. So if or print hello, and after that I'm saying if x is less than or equal to 5, I call the function 1 by sending x plus 1 value. See here. So this is called as a recursive call. This is called as which call here? Recursive call. So within the function, again, you are calling the same function. So that is calling the function itself is called as a function recursion, right? Calling the function itself is called as a function recursion. So remember this. Okay, so this is a recursive call. So what will happen here is, assume that I call the function 1 by sending 1. We call the function 1 by sending the 1. So what will happen? How this recursion is done? Okay, so what will happen? How the recursion is done? Just try to see here. So the execution of my program starts at what here? Main. So first, which function is called? First, which function is called? Main function is called. First, which function is called? Main function is called. And main function calls which function? Function 1 by sending the value called 1. So what is the value of x here? See here. Whenever you call the function, the memory for that function is reserved. Okay, in which it will push all the local variables. So this is a function 1. So it will print the message. What is the message? It will print hello. And after that, if x is less than or equal to 5. So what is the value of x here? 1. Is it 1 is less than or equal to 5? Yes. Then again it will call the function 1. Again it will call the function 1 by sending which value? X plus 1 value. Okay, again it will call the function 1 by sending which value? X plus 1 value. X plus 1 value means what is the X value? 1. 1 plus 1 is what here? 2. So whenever you call the function, so this is function 1 is a calling function here. And this calling function is calling again which function? Same function. Okay, so in recursion, called function and calling function both will be the same. So function 1 is calling again function 1. Function 1 is calling again what? Function 1. So there is a memory allocated for function 1. So the value of X will be what here? 2. So it will print the message. What is the message? It will print hello. Is it 2 is less than or equal to 5? Yes. Again, function 1 is called. So whenever function is called, there is a memory allocated for that function. So there is a memory allocated for that function, and X plus 1 value. What is the X value now? 3. Then it will print the message. What is the message? It will print hello. Then again, 3 is less than or equal to 5. Yes. Again, call the function 1. Again, it will call the function 1 by sending X plus 1 value. So that is nothing but the value of X will become what here? 4. Is it 4 is less than or equal to 5? Yes. Okay, so it will print hello, and 4 is less than or equal to 5. Again, it will call the function 1. Again, it will call the function 1. Again, it will call the function 1 by sending X plus 1 value. So the value of X becomes what here? 5. Is it will print the message hello? And is it 5 is less than or equal to 5? Yes. Call the function 1 again, and the value of, so there is a memory allocated for function 1. So the value of X will be what here? 6. Is it 6 is less than or equal to 5? No. 6 is not less than or equal to 5. Condition is what here? False. So when condition is false, what will happen? Is the execution of this function is over, right? Once the execution of function is over, the control is switched from called function to calling function. Okay, once execution is over, it returns from called function to calling function. But which one is the called function? Function 1. Who's calling that again? Function 1 only. So execution of this function is over. Then return to which function? Function 1. Execution of this function 1 is over. Then return to which function? Function 1. Execution of this function is over. Return to which function? Function 1. Execution of this function is over. Then return to which function? Function 1. Execution of this function 1 is over. Return to which one? Function 1. Execution of this function is over. Then return to which one? Main. Because which one is the calling function here? Main. So when it comes to a recursion, in recursion, calling function and called function both are same. In function recursion, calling function and in function recursion, calling function and called function both are same. So once you run this, now you can see printed hello message. How many times here? 6 times. Okay, right. So there are some complex problems are solved easily by using function recursion, but it is just like a looping statements where you required initialization statement, updation statement, and you also required some condition, right? So it will try to display this message hello. How many times it is displayed the message hello? 6 times. Okay. Suppose, assume that I want to write a program to find factorial of input number. So, but I want to do this without using any looping statements. Sometimes I may ask you like, without using looping statements, try to find the factorials, or without using any looping statement, try to print the numbers from 1 to 10. Without using a while loop and for loop, print numbers from 1 to 10 or 1 to n. Without using loop means immediately you have to think about what? Recursion. Without using loop means immediately you have to think about what? Function recursion. Okay, you have to think about recursion, because in recursion you are trying to repeat the same thing how many times? Number of times. Okay, so write a program to find factorial of input number. I want to find out the factorial of input number. So how can I find out the factorial of input number here? Okay, so for that, yes. So the first step is you have to input the number. Integer of input, enter any number. So this is the first step. So enter any number. Okay. So yes. Now this is the function main. So where I try to read the number, then result equal to, I am calling the function factorial by sending number. Result equal to factorial, I'm sending what here? Number. So then I'm saying print factorial is, I try to print what? Factorial. Then I call the function what? Main. I call the function main, right? So there is a function called factorial, and this function factorial receive the number. Then if number is 0, then 0 factorial is what? 1. So I'm saying return 1. Else I'm saying return number into factorial number minus 1. Else return number into factorial number into number minus 1. So this is which call now? Recursive call. Okay, because factorial function is calling again what? Factorial. For example, assume that, so how it will execute? Now assume that, how this is executed. Okay, assume that how this is executed. Okay, so execution of my program starts at main. So there is a memory allocated for which function? Main function. So within main function, there is a variable called number. Suppose I want to find the factorial of 3. I want to find the factorial of what? 3. So what is the value of number I've given? 3. Then after that you are saying you are calling the function factorial. Which function are you called here? Factorial function is called. Which function is called here? Factorial function is called by sending the number. Factorial function is called by sending what here? Number. So what is the number given here? 3. So there is a memory. There is a memory allocated for. So whenever you call the function, the memory is allocated for that function. So there is a memory allocated for factorial. And what is the value of number here? So the value of number is what here? 3. in this function call, what is the value of number here? 3. Is it number is 0? No. Then it will come to else and return. So here there is a return, right? Return. So what it is returning? So this function is returning. What it is returning? Number into. Means 3 into. Where it is returning to the main. Because who's called the factorial function? Main function. Who called the factorial function? Main function. So to the main function, it is returning what? Number into factorial. Means again it is calling which function? Again it is calling which function? Factorial function. By sending which value? Number minus 1. Number minus 1 means what here? 2. So it means it means what will happen? So factorial function is called again. It is called by sending number minus 1. Number minus 1 means 2. So what will happen? There is a memory. So there is a memory allocated for which function? Factorial. There is a memory allocated for which function? Factorial. So within this function, what is the value of number now? 2. Okay, 2. Is it number equal to 0? No. So again return. Again return 2 into what is that? Factorial of number minus 1 means 1. Means factorial function is calling again which function? Factorial function. Okay. So again factorial function is called by sending number minus 1. Again factorial function is called by sending number minus 1. So what is the value of number in this function? 1. Is it 1 is equal to 0? No. It will come to return number into. Number means 1 into factorial. Again it is called factorial of number minus 1 means 0. So again factorial function is called. Again factorial function is called. Okay, again factorial function is called. So in this function call, what is the value of number? 0. So is it number equal to 0? Yes. Then it will return what here? 1. So where it is written? So return means who called this factorial function? This factorial function is called by this factorial function. And this factorial function is called by this factorial function. And this factorial function is called by this factorial function. And this factorial function is called by whom? Main. Okay, so this factorial function is called by which factorial? This factorial function. So if number is 0, it is returning 1. Where it is returning 1? To the calling function. Who called this factorial function? Factorial only. So it returns what? What it returns here? 1. So then 1 into 1. So it is returning 1 into 1. Okay, 1 into 1. So what is the result of this 1 into 1? 1 into 1 is 1. Now it is returning 1 into 1. So who called this factorial function? This factorial function. So 1 into 1 is returned to here. Okay, then 1 into 1 is 1. Now 2 into 1. This result is written here. 2 into 1 is a 2. Now 3 into 2 is what here? 6. Now 6 is returned to what here? Main. 6 is returned to what here? Main. So what is the result of this factorial of 3? 6. So this is a called function, and this is what? Calling function. So once the execution of function is completed, now it uses a stack. What is a stack here? Stack uses last in. What stack uses? Last in, first out. What stack uses here? Last in, first out. Last in, first out. Stack uses last in, first out, right? So what is the last function call here? Factorial. So this memory will be deallocated and returned to which one? Calling function. After deallocating this, it will return to calling function. After deallocating this, return to what? Calling function. After deallocating this, return to which function? Calling function. Okay. So recursion, this is how recursion will work. Okay. Y fact variable, any result, sorry. This variable is result. Okay. Okay, now once you run this, enter any number 5 and 5 factorial is 120. If I enter 4, 4 factorial is what? 24, right? So what is the name of this variable? Result. So printing, for example, so write a program to print 1 to 10 numbers without using while or for loops. So I want to write a program that should generate numbers from 1 to 10, without using while or for loop. Okay, without using while or for loop. I want to print all the numbers from 1 to 10. So how can I print it? So I just write print numbers. Assume that print numbers is there. So print numbers will receive number. I'll just read what you have written. Shall I read? So print number is one function. And this is main function. So there is a print number. I call print number function by sending the value called, suppose I send the value called 10. What is the value I send? 10. Because I want to print the numbers from 1 to 10. So here what I'm saying is, if n is greater than 0, I'm saying print number n minus 1. Print number n minus 1. So it means I'm repeating this here. What I'm doing, I'm calling this function. How many times I'm repeating this? I'm recursing this until n is what here? Greater than 0. When n is 0, suppose 0 is greater than 0, no. Then it will print. It will print the value of which one? N. If condition is false, it will print the value of n. If the condition is false, it will print the value of n. When if this condition is a false. For example, 10 is there. Is it 10 is greater than 0? Yes. Now recursion means now. So calling function, called function. Until execution of function is not completed, the control will not switch to calling function. So here there is a memory allocated for what? Main. Okay. So main is calling. Now main is a calling function. It is calling which function? Print number function by sending the value called 10. By sending the value called 10. Now there is a memory allocated for which function? Print number function. There is a memory allocated for which function? Print number function. What is the value of n here? 10. Is it 10 is greater than 0? Yes. So what is the value of n here? 10. In this function, what is the value of n? 10. So again, it calls a print number function by sending 9 minus 1. So it means calling function is print num and called function is also what? Print num. Calling function is print num and called function is also what? Print num. So the control is moved from calling function to called. So what is the value of n in this function call? 9. Is it 9 is greater than 0? Yes. So again it will call the function print num. Again it will call the function print num. Now sending n minus 1 value. What is the value of n in this call? 8. So after that again it will call n minus 1. So how many times? Until n is what here? 0. When n value is 0, right? When n equal to 0, in this function call n value is what? 0, right? When the condition is false, it will return to which function? Calling function. So is it execution of this function call is over, right? Then return to which function? Calling function. And then print which value? N value. What is the n value in this function call? 1. What is the n value in this function call? 2. What is the n value in this function call? 3, like this. So it will print up to what here? 10. So you are repeating it. Recursion. You can see 0. Yes, because 0 also there here. 0 also there because I said greater than 0, but I should take greater than 1. So 1 to 10. So it's printed how many values? 1 to 10 values. So recursion is just like a looping, okay, repeating same function until you get the result. Repeating same function until you get the result. Repeating the same function until you get the result. So that is called as a recursion here. Now the next one is, yes, monkey patching. Okay, what is this monkey patching here? Now this monkey patching will be repeated again, but now just try to understand what is a monkey patching in functions. What is monkey patching in functions? So there is one, I think if definition is there, I'll take from here. No, not there. So I'll take from here monkey patching. So in Python term, monkey patching. So this is, so it's nothing but patching. Generally patching is like doing some changes. So in Python, the term monkey patching refers dynamic modification of a class or module. But what is a module here? Is a Python program, right? So in Python, we actually change the behavior of code at runtime. We use above module, mock in below code. What is that? So this definition, we'll see complete definition. But this is related with classes and modules. But even we'll see this. But definition is monkey patching definition is same. That is modifying. Yes. Definition is the same. There's no changes in definition. Patching means modification. Patching means modification. So changing the behavior of code. This is very much useful when you're working with the classes and objects. When you build your own classes, and if you want to do some changes, in the function, but that will be applicable to only local. Local means only to this particular program, not to any other programs. Then you'll go for which one? Patching. This is useful when you're working with modules and classes and objects. Patching is modification. Any other definition is there? We'll see that also. See. Dynamic modification, same definition is there. Okay. So definition is very simple. And if you see the images of this, it look like this. Okay. So patching, so patches, right? Monkey patch. So these are called patching it, some definitions. Okay, for example, a best example, if you see this monkey patching, right? So there is one module. Assume that. A simple example I'm telling you. There is already a module called math. Math module is there. Okay. So what math module is doing is, in math module, there is one function called square root. If I say square root of 9, so anyway, the result of this square root of 9 is 3.0. Okay. Then result equal to math of, if I say square root of -9, then immediately it gives what? Error. Okay. So it means the square root of math, if I give the input as negative, then immediately it gives which error? Value error. So I want to patch this. I don't want this error. If it is a negative, then it should display, or it should return the value as what? 0. Or it should convert that negative into what? Positive, or something, some logic I want to write. Or I want to display the message, you cannot find it, like that. Or it should return what? 0. It should return some 0. Okay. Then how can I do this? How can I overcome this error? Means I want to modify the code. But are you written square root function? No. This is a predefined function or user defined? Predefined. Is a predefined function available in which module? Math module. So you cannot modify this code. This code is there, but you don't modify it. but you want to modify it. You want to modify it locally and you want to apply it, right? Then you go for which one? Monkey patching. So what you're doing is you are trying to write, suppose assume that square root, okay, you are trying to write square root 1. Now square root 1 is a function which receives the number. And here I'm trying to check if number is less than 0. If number is less than 0, I'm saying return what? 0. Otherwise, what I'm saying is return. I try to import. I try to import which module? I try to import which module? Math module. I try to import which module? Math module. See which one I imported here? Math module. And here I'm saying return math dot square root of square root of which one? Number. So this is what I'm doing it. Okay, math dot square root of number. Suppose here what I'm saying is math dot square root equal to square root 1. Now this is called as which one? This is called as which one? Monkey patching. Now this function you apply one patch and ascend. Actually square root 1 is assigned to which one? Square root. It means whenever I'm calling the square root, it is calling which function? Square root 1. Okay, but original square root have done changes? No. Original square root remain what? Same. So the changes are done locally or not? Yes. These changes are done locally. Original square root function will be the same. But the patching is done only inside this program. The patching is done only inside this program. So math dot square root equal to square root 1. So after that, I want to find out the square. Now I just enter the number integer of input. Enter any number. And the result equal to math dot square root of 9. So I just write print result. Okay, print result. Now enter any number. Oh, so it has been a recursion, right? So why? Because here when you say math dot square root, it's calling original function, not this function, but again it is calling which function? Square root function. Okay. Yes. So math dot square root equal to square root 1. Input enter any number, math dot square root of number. Oh, yes. So square root means it is calling which one? Square root 1 by sending the number. Okay. This module somewhere did some mistake here. So this code we'll see again. Somewhere we did mistake. So but here we try to assign. Okay. We try to assign one function. We try to assign one function to another function. We try to assign one function to what here? Another function. We'll write with a simple example. There's a function 1, print a message. Hello function 1. So print hello. So recursion, you should not use it. Function 1 equal to function 2 and called function 1. So this is monkey patching. That's all. Simple example means you can take this. Now hello function 2. So whenever I call the function 1, it calls which function? Function 2. But these changes are only in this module. Okay, in this module. So whenever I call the function 1, so function 1 is patched with what? Function 2. Function 1 is patched with what here? Function 2. So there we have written in recursion. Because of that, it is moving into infinite, right? So it is nothing but one function you assign to what here? One function is assigned to another function. So dynamic changing, right? But the changes are local. The changes are what here? Local. So this you can call it as what? Monkey patching. In Python, the term monkey patching refers to dynamic. Okay, dynamic. Okay, right. Now then next we'll go for so another topic, but this I'll repeat again. Okay. Yes, 3G. Then import CMath. CMath. Import CMath and then return it. Yes. So this is monkey patching. The next we'll talk about so Python modules, modules and packages, right? Let us see about modules and what is it? Packages. Let us see modules and packages here. So Python is already said Python is multi-paradigm. Python is multi-paradigm programming language. Python is multi-paradigm programming language. Okay, it supports multiple programming paradigms, to develop programs or what is that applications. It supports multiple programming paradigms. Okay, to develop programs are what? Applications. Programs are applications. So it's a multi-paradigm programming language. It supports multiple programming paradigms to develop programs or what is that? Applications. So Python supports modular programming. Python supports modular programming. So what is a module? I said in the beginning, right? Every Python program is called what? Module. Every Python program is called module. So generally module is a Python program which is saved. Module is a Python program which is saved with extension .py. Module is a Python program which is saved with the extension .py, right? Every Python program is called module. Module is a Python program which is saved with the extension .py. So module is a collection of variables, functions, and classes. So it is a program. A module is what? A program which contains functions, variables, because every Python program is called one module. So when it comes to the modules, okay, modular programming allows to use the content of or allows to use the content of one module inside another module. So in modular programming, you try to divide application functionality into number of modules, means number of pieces, and each piece can be called as one module. Okay, assume that this is a module 1. Assume that this is a module 1. Assume that this is a module 2. Assume that this is a module 3. So there is a module 1, there is a module 2, there is a module 3. So each module is one program only. Each module is one program. So module 1.py, module 2.py, and module 3.py. So each module is having some variables as well as what? Functions. Okay, it means you try to divide your project related things into what? Number of modules. You try to divide your project related things into number of modules. There's a function 4, there's a function 4, there's a function 5, there's a function 6, like this. Okay, it means you try to divide your application related things into number of modules. Function 8, okay, function 9, like this. Then when you required, you try to use the content of one module inside another module. I can use the content of module 1 into module 2, module 2 into what? Module 1. I can use the content of module 2 into module 3. I can use the content of module 3 into what? Module 2. I can use the content of module 2 inside what? Module 1. Sorry. I can use the content of module 3 into module 1. And I can use the content of module 1 into what? Module 3. Okay, any reusable means you are trying to use the variables and functions of one module, inside what? Another module. Variables and functions of one module, inside what? Another module. So that is what you are doing it here, right? So these modules can be, these modules are two types. One is predefined modules, and second one is user defined modules. So predefined modules. So the modules which comes with Python software are developed by somebody. Python software are called predefined modules. The modules which comes with the Python software, whichever modules comes with the Python software, so that modules you call it as which one? Predefined modules. Okay, that modules are called predefined modules. Example is math module, date time module, OS module, sys module. Okay, all these are what here? Predefined module, like built-ins module. So all these are which one? Predefined modules. So apart from that, you develop your own modules. So that you can call it as which modules? User defined modules. The modules developed by programmer are called user defined modules. So whichever modules developed by programmer, so that modules you call it as what here? User defined modules. The modules developed by programmer, so that modules you call it as what? User defined modules. So you write the programs. Okay, you write the programs. For example, you are developing project for a bank. So assume that this is my banking application. Okay, assume that this is my banking application. And what I'm trying to do is, I'm trying to divide my banking application into number of modules. I'm trying to divide my banking application into number of modules. Okay, assume that there is a module called accounts.py. So accounts.py is a module which contain all the functions related with accounts, like opening account. So there is a function called opening account. There's a function called which one? Update account. Okay, there is a function called which one? Delete account. So these kind of functions, okay, there is a function called which one? View account. So the functions belongs to the accounts will be there in which module? Accounts module. There's another module. Suppose assume that transactions.py. So this module is having all transactions related functions. So there is a function called deposit. There is a function called withdraw. There is a function called overdraft. So like this, the functions belongs to the transactions will be there in which module? Transaction module. So there is another module like reports.py. So this is which module here? Reports module. This is which module here? Reports module. So what this module is having? All reporting related functions. So there is a monthly report. So there is a monthly report is one function. Yearly report is one function, like this. So reporting related functions will be there in which module? Reports module. It means my application is having so many functions, but those functions you try to divide. Those functions you try to divide. Okay, so application related functions you are dividing. Application related functions you try to divide into a number of modules, and each module is having number of functions, so that you can easily identify these functions belongs to what? Accounts. This functions belongs to what? Transaction. So maintaining your application becomes what? Easy. So it will provide modularity. It will provide modularity as well as reusability. Modular programming, modular programming provides. Okay, modular programming provides modularity. Okay, modularity. Okay, modularity and reusability. Modular programming provides modularity and reusability. Modular programming provides modularity and reusability, right? Okay. Now here, so that is what is the meaning of modular programming and what is a module? Predefined module and user-defined module. Then how to create a module? Module is nothing but program only. A module is nothing but program only. You'll say file new. Okay, now every Python program is one module. So module is saved with the extension .py. Okay, every Python program is called one module. Yes, every Python program is called one module. Every Python program is called one module. Okay, which is saved with the extension .py, which is saved with the extension .py. Okay. So how to write a module means writing a Python program only. Suppose I write a program with some number of functions. So this is a function 1 and this is a function 2. There is a function 1, there is a function 2, there is a function 3. So all these are what here? Functions. So this is one program. Rather than saying it as one program, I can call this as one module. Rather than saying it as a program, I'm saying this as one module. And this module is having how many functions here? 3 functions. So that is a function 1. So that is a function 1, function 2, and function 3. Is having 3 functions. That is function 1, function 2, and there's one more function called which one? Function 3. So I cannot execute this module. So can I execute this module? No. So because this module or program doesn't have any executable statements. Is it any executable statements inside this module? No. There's no executable statements inside this module. Is it any executable statements are there here? No, there's no executable statements. So the modules can be 2 types again. So the modules are user-defined modules are 2 types. So user-defined modules, because every module is one program. 2 types. One is executable module and one more is non-executable module. So user-defined modules or programs are how many types here? 2 types. One is called executable module and one more is called what? Non-executable module. A module or program which is having executable statements, is called executable module. A module or program which is not having executable statements is called non-executable module. Which is having executable statements is called executable module. Which is not having an executable statements is called a non-executable module. which is not having non-executable statements. Executable statements is called not having executable statements. Means if you see this, this is not having any executable statements. We write a functions, that's all. Are we called these functions? No. If I'm calling the function, calling function is executable statement. I call function 1, function 2, and what? Function 3. Now this you can call it as executable module. If I'm not calling this, then it is which module? Reusable module. So non-executable modules. Okay, non-executable modules. So non-executable modules are reusable modules whose content can be used. Whose content can be used inside what here? Another module. Whose content can be used inside what? Another module. You are trying to use the content of one module inside what here? Another module. Okay. Yes. But how to work with this executable and non-executable modules in detail? But tomorrow I'll tell you this, like how to use content of one module inside another module, like what is import statement. So generally how use the content of one module inside another module using import statement. And there are different syntaxes of using import statement. So there is a multiple syntaxes are there. Okay, function based modules. It means a module which contain only functions. Class based modules means we have not come across classes. Okay. So once we move to classes, then we'll talk about this. So connecting one module with another module. Connecting means using the content of one module inside another module. Okay. Yes. Then we'll see all this like renaming module alias and how to import. And then even we'll see this packages. And once we complete this, we'll move to. Now these topics will be, because all these are libraries. Like regular expression is one library, working with files, logging, all these are simple topics. So this will not take much time. Okay. So we'll try to complete as early as possible. Right. Okay. So we'll stop it here today and tomorrow we'll continue this. Right. Thank you. NumPy. NumPy. NumPy arrays. In NumPy, you'll learn arrays. In NumPy. वेरिएबल नेम नहीं है, फंक्शन नेम नहीं है, तो ऐसा। हाँ। क्यों? दिखाइए बाद में, सिस्टम में है क्या? क्वेश्चन लेके आइए, लैपटॉप है अभी, लेके आइए। नहीं।